Hi, it's me. You may know me from my videos about space and astronomy, but today we're going to talk about something very different. Today we're going to talk about dinosaurs. More specifically, we're going to talk about the day the dinosaurs died. And here's the question that I want to answer today. What was the impact like when the asteroid struck the Earth? So 66 million years ago, an asteroid or comet, we don't really know, struck the Earth with such force that it killed off all the dinosaurs. We know that much. But what was the impact like? We have some clues from the geologic record, but what do they tell us exactly? And are there any surprises in store for us? Let's find out. This is a post from my channel. This asteroid impact was not the first one that humanity learned about. We knew about these things called impact craters long before we had evidence of the Chicxulub impact. For example, this guy, the Vredefort crater in South Africa, is nearly 3 billion years old. That's almost certainly a meteorite impact. We don't know exactly when life began on the Earth. But this crater is more than 500 million years older than the oldest fossils we've found. So there were asteroids raining down on the early Earth for hundreds of millions of years after the planet formed. And the Earth was bombarded by other things too. It wasn't a nice place to be alive in those days. But then nothing happened. Life got going, started to diversify, and then suddenly, 66 million years ago, a bunch of non-avian dinosaurs went extinct. We also lost many other creatures like the ammonites and many others. Some people say that the extinction was actually good for us because it cleared the way for mammals to become the dominant land animals. And that would be true, except that humans weren't around back then. There were mammals, but they were small proto-wombats, basically, so there wouldn't have been any human civilization until several more million years. So yeah, I guess it doesn't really matter if the asteroid did wipe out some of our ancestors. We just don't know about them yet. And anyway, let's not kid ourselves. The asteroid impact itself would have been bad news for whoever was around at the time. But that's not what we're talking about today. We're talking about the aftermath, how the asteroid changed the Earth forever. Or did it? In fact, we can find clues in the rocks about what the asteroid impact was like and how it changed the environment on the Earth, if we read them correctly. To understand what the rocks are saying, we need to get to where the asteroid hit. Well, at least what's left of it. Because over the millennia, erosion has worn down the top of the asteroid impact. And geologists believe that the original crater was roughly 200 kilometers wide and 30 kilometers deep. They call this the Chicxulub crater, named after the town nearby where it was first identified. When we study asteroid impacts, we often look at the impact winter that happened right after the asteroid struck. All the dust kicked up into the atmosphere blocked sunlight and caused temperatures to plummet. A year without summer is a pretty bad time to be alive unless you like the cold. But many animals couldn't regulate their body temperature and died. It's believed that only birds, which could fly south for the winter, and mammals who could hibernate, survived the impact winter. And then there's the acid rain. When the asteroid struck, all the rock vaporized and mixed with water and nitrogen in the atmosphere to form sulfuric acid. This stuff fell back to the Earth as acid rain for weeks or months. Acid rain leaches metals from rocks and soil, so no plants could survive. And if there were any animals that weren't already dead, they starved. No animals means no decomposers, so no recycling of nutrients in the ecosystem. And without plants, there's no oxygen in the atmosphere. So basically, the Earth became a lifeless blob of rock and toxic soup. We can see signs of the impact winter in the geological record. Immediately after the asteroid struck, there was a thin layer of iridium deposited across the globe. Iridium is rare on the Earth's surface, but it's common in asteroids. We can find this layer in rocks all over the world. It's called the KPG band. K stands for Cretaceous, and PG stands for Paleogene. It's called that because it marks the boundary between the Cretaceous and Paleogene periods, and it tells us that whatever happened, it happened quickly. Geologists use a number of techniques to date rocks. One of them is radiometric dating, but that only works if you have enough material to take a sample from. A better technique is to look for a layer of ash in the rock record, Ash from the burning forests dates to 74 million years ago, and that's very close to the date we get from the iridium layer. In fact, we can use radiometric dating on the ash to get a precise date for the death of the dinosaurs. But we can also use the ash to learn something else. When an asteroid strikes, it causes wildfires wherever it lands. And this isn't just because of the heat from the impact, it's also because of the enormous shock wave that radiates outward from the crater. This shock compresses the air and heats it like a stroke of lightning. So there's not just a forest fire right at the impact site, but forest fires all around the world. And that's why we find ash layers all over the place. So when scientists dated the ash layer in New Zealand, they got a date of 66.049 million years ago. But when they dated the ash layer in Tunisia, they got a date of 66.033 million years ago. So depending on where you were on the planet, the asteroid impact killed off the dinosaurs at slightly different times. But wait, it gets weirder. When they dated the ash layer in Texas, they got a date of 66.032 million years ago. This ash is younger than the other two by almost 2 days. If the impact happened somewhere in the western United States, then the time difference makes sense. The Pacific coast is on the far side of the planet from New Zealand, so if the ash was traveling east, it would take 2 days to get there. But the Texas ash predates the New Zealand ash. So it seems like the impact actually happened earlier in Texas than it did in New Zealand. And this is weird because an asteroid striking the middle of a continent should cause an even bigger impact winter. The closer you are to the equator, the higher your chance of survival. That's why people go to Florida to escape the winter. And of course, the Earth was a lot warmer 66 million years ago. So it seems like the impact winter would have been worse in Texas than it was in New Zealand. And if that's true, then why did the ash arrive in Texas after it arrived in New Zealand? Could the impact have happened earlier in New Zealand? Not likely. The ash layer there is right on top of the Cretaceous rocks. There's no gap where you could fit another 2 days worth of ash. And it's the same story in Tunisia. The ash layer is right on top of the Cretaceous rocks. So the impact must have happened later in Texas. And if the impact was later in Texas, then the impact winter must have been worse there. But why? Why would an asteroid impact be worse in the middle of a continent than on the coast? We still don't know. One idea is that the actual energy of the impact might have varied depending on where it struck. Remember, this asteroid was about 10 kilometers wide, so it wasn't a perfect sphere. So maybe it struck Texas harder than it struck New Zealand. Or maybe the asteroid wasn't homogeneous and its density varied across the surface. Maybe there were parts of it that were softer than others and it compressed more when it hit the ground. Another idea is that the asteroid didn't explode all at once. Maybe it rained down meteorites for days or weeks. But if that was the case, we should see more iridium in the rocks below the ash layer. But we don't. And that's not the only thing we don't understand. When the asteroid struck, it threw up huge amounts of sulfur into the atmosphere. And we know that because the acid rain killed off all the trees in the forests, so they couldn't absorb carbon dioxide from the atmosphere. So we expect to see a sharp spike in carbon dioxide levels. But when we look at the carbon isotopes in the rocks, we don't see that either. We see normal levels of carbon dioxide, maybe even lower than normal. And there's even more. The acid rain should have lowered the pH of the ocean. But again, when we look at the chemistry of the oceans in the rock record, we don't see any change. So the asteroid impact might have been a lot smaller than we think. We still don't know exactly what killed off the dinosaurs. Maybe it was the impact winter. Maybe it was the acid rain. Maybe it was the carbon dioxide. Or maybe it was the lack of oxygen in the atmosphere. Maybe it was all of the above. But clearly, we need to keep looking at the rocks to try and solve this mystery.